In the previous lecture, we talked about theoretical probability, and we drew Pascal's triangle, and we talked how it was binomial or two outcomes. Let's suppose I have a coin, and I'm going to flip it 3 times. My first flip is a head. After that, I could have gotten a tail or a head, and on the third flip, I could have gotten a head or a tail, a head or a tail. So if we look at the outcomes here, I have 1 across, and then this branch is 2, 3 down, and then this branch is 4. So there are 4 different outcomes, but that's only if my first flip of the coin was a head. What if my first flip was a tail? Well, I could repeat. I could have gotten a head or a tail on the second flip, and then a head or a tail on the third of each of these. So if we look, it's kind of the same pattern. It's just the almost what we call the complement, the opposites. There are 4. So it looks like there's 8 possibilities. If you recall base 2, the first flip I had 2 outcomes, either a head or a tail. The second flip, because it had nothing to do with the first, I could have gotten a head or a tail. And then the third, a head or a tail as well. So I have 8 possible outcomes. And if we want to track these outcomes, we can kind of see it here. There's 1, 2, 3, 4. That's why we had 4. If my first flip of the coin was a head, here's when my first flip is a tail, and again I have 4. So there are 8 total outcomes. Well, how does this relate to Pascal's triangle? Pascal's triangle has to do with a binomial, like we showed earlier in algebra. If you total the 1, 3, 3, and 1, it totals 8. So looks like we might have 8 outcomes. But how do each of these numbers relate to probability? Well, if we take a look, this one is when I absolutely have 0 heads. So let's look. How many times did I flip this coin and only end up with tails? Right here, 1 time out of the 8. The next situation is what happens, or how many times will I just get 1 head in my sequence. So if we take a look, there's where I got 1 head. I got 1 head here, there's 2, and I got 1 head here, there's 3. So the next situation is when I get 2 heads in my flip. How many different times did I get a head twice? It looks like there should be 3. There's a head and another head with a tail. That's one option. There's another head and a tail. There's 2. And over here, it looks like I have a tail, a head, and a head. 3 options. There's no other times that I get just 2 heads. And lastly, this would when I get all 3 of my flips to be heads. And I think that's the only one in which we haven't calculated here. So all 3 are the same. And here they are, head, head, and head right there. So that's how Pascal's triangle is used for binomial probability. It finds those for us every time.